This is the 5th of 7 videos relating to index laws and index notation. Some textbooks in some places refer to the 7th law as both the 6th and 7th law. So some textbooks combine them together, some split them up as two different laws. We're going to look at them as one law. So our learning goal here, once again, is to use our knowledge of index laws to simplify and solve problems. In particular, we're going to look at the 7th law, but we are going to apply some of the other laws as well. So the 7th law is related to fractional indices, that is, where the powers are fractions. These fractions can be written as radicals, which is a fancy way of saying square roots, cubed roots, etc. So that's the mathematical language. Radicals are that square root sign. So here's an example. A to the power of a half, that's a fraction. It's equal to the square root of a. So they're just interchangeable ways of expressing it. The reason we do this is because we can't do much with a square root, but if we put it in as a fractional index, we can actually use the other laws to combine them with integer values like a cubed or a to the power of 4. So here's a to the power of a third, that's the cubed root. You'll notice there's a pattern here. One of the things you need to remember about the square root is that by default means 2. There's no number there, it means 2, because square root is the opposite of power of 2. This is the actual law itself. A to the power of 1 over n equals the nth root of a. That's what that means, nth root. So the denominator goes to the front of the root, or on top of the root. The a, the base, goes inside the root symbol, the radical symbol. The more complex version is this one here, where the denominator is not, the numerator is not equal to 1. So in this case, the denominator still goes to the top of the root there, the radical sign, but this bit here is actually like a to the power of m, so it goes inside the radical, the square root sign. So you know the denominator of our fraction is the radical, and the numerator is the power inside the radical. That's what you need to remember. So square root is the inverse or opposite of squaring. The inverse of squaring 3 would be taking the square root. So if we look at that, 3 squared, we take the square root of that, that cancels out our squares. We get a number of 3. We know that from grade 7 and 8. If we look at that in terms of radicals in our rules for fractional indices, the 7th law, we see that this square root can be written as power of a half. So all of that 3 squared is to the power of a half. And now we can apply our 4th index law. So that means we multiply the 2 there, the power of 2, times the power of a half. 2 times a half is 1, and 3 to the power of 1 is just 3. So you can see that it actually proves that this does work. The square root is actually power of a half. So here's an example, 16p squared. What we're going to do is use the 7th law first, and then simplify that further with the 5th law, the power laws. So the 7th law says this is a square root, so the power of 2 there. We split it out as power of a half. So all of that is to the power of a half. The 4th law says we need to put 16 to the power of a half and p squared to the power of a half. So here it is here, 16 and a half, p squared to the power of a half. And we can then simplify that. Now 16 to the power of a half is also the square root. That's what we just talked about. So 16 to the power of a half is actually 4. P squared to the power of a half, we multiply those indices, 2 times a half, and we get p to the power of 1. So we don't need the 1, we know that, so it can be written as 4 to the power of p. Here's another example, slightly more complex because it's using a cubed root. Let's look at how that works. Once again, we write that in terms of a fractional index using the 7th law. So cubed root is the same as power of a third. Remember, this here becomes the denominator. We apply the 5th law to split up these two terms to the power of a third. We get 8 to the third and j to the 6th to the power of a third. So we're going to multiply those two using the 4th law, and then we're going to apply that law there. So remember, power of a third is actually the cubed root. So what number multiplied by itself 3 times gives me 8? Some of you may recall that's 2. 2 cubed is 8. So this bit becomes 2, and we multiply 6 by a third. So On the next page, let's simplify this 6 by a third, and we get, say it's dividing by 3, so 6 divided by 3 is 2. And I apologise, there is an error there. Let's fix that up now. That actually equals to the power of 2. Here's another example. This one's starting to get a bit more complicated because when we look at this, some of you may recognise this is not going to be a nice, neat answer like the other ones where the fractions cancel out. So we've got the fifth root here. That means to the power of, remember that number there goes to the denominator. So use the seventh law, and everything in that bracket is to the power of 1/5. Now we use the fifth law to split up these two terms, two parts of the expression. So 30 to the power of 1/5, x cubed to the power of 1/5. Now this here, fifth root of 32, you can do it on your calculator, but some of you may recognise that this means what number to the power of 2 will give me a power of 5. What number to the power of 5 will give me 32. That's 2 times 2 times 2 times 2 times 2 is 32. It's over here. So you, like I said, you could type that in your calculator. Fifth root of 32 or 32 to the power of 1/5. Your calculator handles both of those really well. Over on the right here, 3 times 1/5 using the fourth index law. So 32 to the 5th is 2, and there's our fourth index law there. Let's have a look. That simplifies to 3/5. Now, we don't usually write things in terms of fractional indices, particularly where the question starts with a square root. So let's simplify that by putting it back to the radical sign. So the denominator goes to the front there, like so. So this bit here is the front of the radical, and the numerator goes inside next to the base. So that's the seventh index law, and that's actually the last of the index laws. There are 7 in total. Some questions will involve using all of those laws together. Some might only use 1 or 2. The more index laws we apply, or ask you to use at a time, the more complex the question gets. So the A-level students are able to do or use most of those laws in one particular problem.